started. How exciting at the end of week 4. Hello everyone. I don't even know what day it is. It's Thursday. And week 4, so you're almost halfway through the course. Next week, I'm not here. You will have Andrew Taylor doing Monday's lecture, and Tammy will do the lecture on Thursday. That will be a really helpful lecture for your assignment. I will be somewhere in sub-zero temperatures enjoying the cold, unlike you all that will be enjoying 30 degrees, and spreading the beauty of DCC, which will be very exciting. So, so that will be your week 5, and you will be starting pointers. So I'm just letting you know, so you have the weekend to prepare yourselves and feel okay about it. For those of you that don't know what pointers are, just spend the weekend preparing yourself for the thought of it. All right, so last lecture we reinforced one-dimensional arrays, and it was very exciting. Hopefully you understand arrays a little bit better, because we're going to keep working with them for another few weeks, really. Well, more than a few weeks. But we will predominantly focus on them for another few weeks, because your assignment is also all about arrays. And we also started looking at two-dimensional arrays, so an array inside an array, which makes up a grid, and basically your whole assignment. So for those of you that in the assignment stream, which happened on Tuesday, for those of you that wanted, that were a bit upset that they couldn't make a GUI game out of it, and were a bit sad about it, I've put up a little challenge for you on the website. And if you want to, it's in the challenge. It's not for marks, it's just for fun. Using a special library splash kit. I did an example for you of how you can use it. You've got to do a bit of reading, a bit of fun, but you can actually create a graphical user interface for your game if you wanted to and if you had time. But it's an extra challenge. It's not for marks. It's not compulsory. It's just for fun. For those of you that want to have fun that way. So that's fine as well. But yeah, so you can have a look at that on the website. Okay, today a few people have asked me about Control D, so we're going to just have a quick chat about Control D and what it means with scanf. We will then do a little recap of 2D arrays, and I thought that we could move a few things into functions, because the program that we finished Monday with was, I'd probably give it a 1 out of 20 for style. It was pretty bad, so we will revisit that and move some things away into functions as well. And then finally, we're going to do strings. So very exciting. And then if there's time today, I'm going to talk about command line arguments, because they go really well with strings, because they are really a whole bunch of strings that you receive on the command line. So that's the plan for today. Live lecture code, I think Sophia has already shared it in the chat. She's way ahead of time. So let's quickly go back to our two-dimensional arrays, and then we can move on from there. Okay, so a two-dimensional array, an array of arrays, basically has a number of rows and a number of columns. So it creates something that looks like a grid. So the number on the inside is the number of rows, then it's the number of columns. Visually, it looks something like this, where you can access each grid element by specifying which row you want and which column you want. So if I want something at row 1, column 2, then I would do array 1 in square brackets and then 2 in square brackets, and that says I want something at index at row 1 and column 2, and that will help me access whichever element that I want inside that grid. Okay, so let's go back and let's have a look at the last piece of code that we wrote, and then based on that we will move some things into functions as well. So this is the last piece of code that we wrote on Monday, and what this question did is it looped through the array. Well, it had 3 loops, so really it did a lot. So first of all, it used a loop to scan things into, and it kind of kept scanning things in here. As long as the number of columns was happening. There was no error checking here, so we can look at that as well if we want to kind of talk about what scanf is doing as well, and whether or not we should error check in here in case someone puts in something else. So in here we were scanning into each index of the two-dimensional array, and we were putting things in, the numbers that we specified on terminal. Then in the next section, we had a 4 inside a 4, which is how we access our two-dimensional array elements. And in here, we were printing things out. And then the last one, we were figuring out how many even numbers there are. Yeah?
Does the style guide specify how many nests we're allowed to have? Because I couldn't find them.
So, do you mean like a...
How many layers of nested stuff?
Like a nest inside a nest inside a nest inside a nest?
How many of those are okay?
Oh, it should have.
I looked through it, I didn't find
You should
it.
start questioning your life choices at 3 nests, I feel. And then try to move things into functions at that point.
What if you want to print a 4-dimensional array?
Well, I mean, yeah. Okay, that question was about how many nests you should have inside, how much nesting you should go into. Sophia's just going to look what's there in the style guide. She's looking through it now. But I was just saying, you know, just be careful nesting into nests, into nests, into nests, because that's very messy code to read. And it's very easy to make mistakes and very easy to stuff something up. And one way to get rid of all this nesting, nest upon a nest upon a nest, is to use functions. So you should, now that we know about functions, we should start using functions. Oh, good. We don't have it in the style guide, so I guess you can, you know, nest to your heart's content. But that's not true. Don't nest to your heart's content. Very difficult to read your code. Very difficult to mark your code. And just bad code style to nest. So much. Obviously, sometimes you have to nest a little bit.
I mean, if it's given that you can pass in arrays and they are, like you said, decaying pointers, technically you could just have one thing to print every element in array and then call that recursive?
Well, you could, or you could just do smarter code that doesn't kind of require... Oh, yes. In the marking guideline for the assignment, we give you a little bit more specifics of how much nesting you should do. I feel like, yes. Are the assignments checked by real people too? Don't know. No, they are. They are checked by us. Not if you are, obviously not if you're passing every auto test. We don't really look at your assignment then. But we do look at your assignments to give you the most possible marks. So they are marked manually by your tutors. Please make your code readable, because if your tutor can't read your code, they can't really mark it properly. And what is nesting? No one, okay. Nesting is when you have a loop inside a loop, inside a loop, inside an if statement, another if statement inside that, and you keep nesting all of your statements and your loops inside one another at a certain number of levels. So it becomes really hard to read and understand what's going on. Yes, it is very hard work to mark that many people, so we usually try and do a 2-week turnaround, but sometimes we're a little bit late because there are a lot of you in this course. So we do try and look at everyone's code as well. Okay, excellent. So let's, who wants to suggest to me what we can move out into a function? I think the printing. The printing is always a good one to move on out. All right, let's move the printing out into a function. Okay, so I would like to move this piece of code . Oh, what is happening? Oh, I'm in light mode as well. No one's even commented. My goodness, I can't believe it. All right, everyone feeling better? Okay, let's do it. What is happening? Okay, so let's move this printing into a function. Okay, so if we have a function, be the input to this function and what will be the output? Input into a function that's printing something? Yeah, an array. That would be a good thing. What about output of this function? Void. Excellent. We are not returning anything from this function. Okay, so void is the return type. Let's say it's called print array, and we're going to give it our array. So int array, and should we specify the size of the array that we're giving it? Who's saying?
Yeah.
Who's saying yes? One person saying yes. Who's saying? A few people saying yes. Who's saying no? One person. We do have to specify the size of the array, otherwise it doesn't know what on earth is going on and you're going to start accessing garbage. So we do have to specify what the size of the array is that we are accessing. Yes?
You said usually you have the memory allocated for an array is specified at compiling, right?
Yeah.
You said there's also a way that you can, dynamic arrays or whatever, that you can specify at runtime, right?
So there is a way. Andrew will look at it in...
So if we did that, would we have to specify in the function the size?
You still have to know this. You still have to know the size of the array that you're going to reallocate to. And dynamic allocation of arrays is really, it's not really, it's just a way to show you how to use memory allocation. It's not, it's very messy. It's not really, you would use a linked list in that case if you needed dynamically allocated memory.
Right.
It's hideous. The question was about dynamic allocation of arrays, because you have to only double the size of the array that you already have. You can't really do specific things with it. Okay, so let's move it out. We've got to specify the size of it. I'm just going to cut this out and move it in here. Okay, and in here we're going to call the function. So the function is called print array, and we're going to give it our, I forgot what the array is called, array2d. Okay, and we want to really give it the size of the array as well. Okay, so there is a way to do it, and we can either give it the size in here, like we can specify size, like I can say, okay, we're going to get max rows, so that means that the function will have 3 inputs into it. So, and that means that in here, you would give it an array, and then you would have a max rows and max columns. So you have an int. That's not a good way to do it. No, stuff that. No, we're not going to do that. Okay, we're going to do it like this and call it a day. Okay. All right, and so then it will pulse through the array and it might print it out, we hope. And that will be very nice for us. So let's see if that works once the... Actually, what am I missing in here? Yeah.
Oh, no, I was asking a different question.
Okay.
The question was, is there a way you can print out just one bit of the array without putting the whole array in the function?
Well, you could have a function that prints out just one element. So you could just printf one element and point the index to that.
Yes. Put the whole array in the function, though?
It depends what your function is doing. So if your function is just printing out one single, you could have a function that prints out one single element, then a function that prints out a whole array. If you want to print out just one thing, you would probably just point to it as the one thing that you want to print out. And one thing probably wouldn't need a function to go with it. So we do a function because we're traversing through the array and there's a bit more involved. Yeah?
I think he meant more like, can you pass in, say, only the first half of an array or something as a parameter?
Oh, so once you do pointers, you can pass the start of the array as something else. And you can start it halfway and then it won't see the beginning of it. And a size that you want to go to. You could do, but it gets messy then and it doesn't make as much sense in a piece of code. Yeah, and then in your function do the logic for starting from somewhere else. Depending what it is that you need to do. You can do everything that you want to do. It's just how you do it and what you need to do for the question. Okay, so prototype. Let's do a prototype now. No doubt, I probably missed a semicolon.
You've got max rows and max rows as well.
Oh, that's good. Look at me go. I do. What is it actually? It's just max row and max column. Oh, what is happening to me today? Yeah, it's not. It's because I installed Vim as well. So now it's running Vim in the back. Don't even. All right, and let's put that in as a prototype to start with. Okay, so now let's run it. All right, here we go. All right, so let's see what's going on and what has been stuffed up. Quite a few things have been stuffed up. What have I done here? Forgot a semicolon. Excellent. Living the dream today with my semicolons. Okay, let's try it again. So only look at the first error, try it again. Something else is wrong. What else is wrong now? Okay, so what have I done? Say it again. Nope, array 2D.
You're trying to print an array, but you're trying to access an element of that array and then call it an array.
Exactly. Okay. So in here, when I have called a function print array, okay, what I've given it is array 2D, and then I gave it max row, max column. Okay, max row is 3, and max column is 3. So what I'm actually giving it is array 2D, index 3, index 3. Okay, so what I've given it is an element of the array that actually doesn't even exist. Okay, so I'm now out of bounds as well. So when I call the array, I will do this, and then inside here I'll specify how big that array is just because I have those hash defines. Okay, so let's try it again. Okay, so let's see what this error is. Okay, and you're going to see quite a bit of that. Okay, so let me fix all of that because I haven't defined them anywhere else. So these are the kinds of errors that you will see with your assignment as well, because these are the kinds of errors that happen a lot. Okay, and then finally, what is happening? Final error, use of undeclared identifier in line.
In the function you refer to array 2D, but the argument is array.
Thank you. Okay, so now because I've moved it down, and before it was array 2D, but now inside here I'm calling it int array, and that means that it is now known as array, which is why this now has to say array. Okay, let's try this again, and it's compiling, and now let's run it. Okay. Okay, so there we go. So now it's working again. What else can you move into a function now? Shall we move the one that checks for even or odd numbers? Let's do that into a function. Okay, excellent. So now let's move our checking for even. What should we call it? Let's call it check even. We're going to give it something, and let's do it over here as well. Okay, so this function will check for the number of even numbers in the 2D array. Okay, what's the input into this function? And what's the output out of this function? Inputs into a function that will take an array, a two-dimensional array, and check it for how many even numbers it has? Array. Yep, the array, excellent. And what's the output going to be?
addition, I'm assuming it's outputting the number of even. So
What if I don't want to print, I want to return something? What would I return?
it's returning an int, but then out, like it's not printing it.
Yeah, okay, so it's going to return an int, which is going to be the number of even numbers that this 2D array has. Yeah. Okay, so let's do that now. Okay, so I'm going to send it off on its merry way with array 2D. And we'll talk about, because it's going to return something as well. For now here, I know that I'm going to give it it's going to return an int for me. So my first keyword is int. And I've forgotten what I've called it, check even. Okay, check even. And I'm going to give it an array that's going to have, I'm not going to make it plural now, max row, max column. Okay, excellent. So now, let's see what else will need to be fixed. Anyone? Pardon? Yeah, so first of all, we need to declare these because they haven't really been declared anyway. Yeah, this array 2D is now referred to array because that's what I've copied it into. So now it's going to be array. We're going to do that, and then I have to return something from here. What am I going to return? Yeah. So I'm going to return the even counter because that's what got the number of even numbers in it. And that means that over here, I really want to be checking. I want to be putting this return into something as well. Or what I can do is instead of having this even counter here, I can just call this function inside my print statement. And when it returns the int, it will placeholder it into this %d. Okay, and I'm just going to remove it from the even counter from here. And that means also that even counter has not been declared here. So I'll declare it inside here as well. And, of course, my function prototype. Okay, let's try that out. So compile it again. Okay, there is something to do. I've got somewhere. An extra semicolon. Instead of just forgetting it, I've got an extra one. Okay. And of course, I forgot to initialize it as well. So there we go. Let's see what happens now. All right. Okay, so now we've got it working, and we've got it running with two functions as well. So the code now looks a bit neater as well. Okay, how is everyone feeling about functions? Tom, online, can you do a poll, please? In the theatre, how are you feeling about using functions with arrays? Can you raise your hands if it's okay? Okay, kind of, a little bit, semi, and okay. Let's keep moving then. Let's do a problem with two-dimensional arrays. Okay, let's write a program in C that will calculate diagonals of an array. So for example, if I have an array 1, 2, 3, 4, 5, 6, 7, 8, 9, I want to calculate the sum of the diagonals, so these ones here to start with. So what's so special about this diagonal, about the rows and columns? How can I pick them? Yeah, okay, you're just getting on the chocolates. Okay, so in here, if you notice, my row and my column are always equal on this diagonal, so I'll always have the same index. So this is one way that I can pick the diagonals out to actually work out this problem. So we're going to do the sum of those. It hates me today. Okay, here we go. We need 2 loops because we need to go through the array. Actually, we don't have an array, so first things first, we probably need an array. Okay, so to be faster without using scanf, let's declare and initialize a 2D array. Okay, and let's int array. Okay, so declaring a 2-dimensional array, that means it's size 5 by 5, and that's a terrible size because now I'll have to initialize it and it'll take me too long. I'm going to go back to 3 by 3, only because it's faster. Okay, and let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now it the 2-dimensional array actually looks like that. Okay, so now that we have an array, let's do our nested for statements so that we can traverse through the whole double array. Okay, so for in row is equal to 0, row is going to be less than max row, row plus plus, and then inside there we're going to have the same thing for the columns. So int col is equal to 0, column is going to be less than max column, column plus plus. Okay, and so you said to me that we're going to add it up if the row is equal to the column. So what do you think is going to be my statement that will check for that?
If row equals...
Hey? I can do that, but it's easier to understand when you're a novice to have 2 for loops. I can do many things in much shorter sections. Yeah?
For example, you could have the entire thing in one single
I could, well, yes, but yeah.
If row double equals col.
Yeah, okay. So then we can check inside here if row is equal to column, then I'm going to add it up. So if row is equal to the column, then what I'm going to do is I'm going to add it up. So plus whatever is sitting inside that array at the index row column. And that means we should also initialize it here. Okay, and then we'll print it out. So let's see if that does anything. Okay, compiles. So now let's run it. And the sum is 15, which is correct. Okay, does anyone want me to run through it line by line?
Question?
Yeah.
So you know how with enums we can say one of them is equal to like 5 or whatever it is to start counting from like 5, 6, 7. Can we set a negative number?
You can, as long as it's in, like it's, and it has to be a numerical value.
Okay. So
Yeah.
can you have, like, is there any way to like shift the index of a array?
No, those are set. Yeah.
You have to have a variable which you minus from the
Yeah.
value.
Yeah. Okay, so let's line by line or not line by line? I feel like the first two rows are a really bad audience, judge of audience. Because I'm getting a very different vibe online to these three rows. Yeah, okay, line by line, Sophia's nodding. All right. Okay, here we go. Hope everyone's enjoying my looping and looping and looping and looping some more. Okay, so we go into our main function and we have a variable sum right, and that variable is initialized to 0. Then we declare an array, and I'm just going to draw the array up because otherwise it's going to be too hard to write it as separate indexes, but I'll label out the indexes. So this is row 0, row 1, row 2. This is column 0, column 1, and column 2. And inside is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so that means my array is now declared and initialized, and I move on to line 19. I declare int row, I initialize it to 0. Then I check, is that row, which is 0, is it less than max row, which is 3? Yes, it is. So I go inside this for loop, and I initialize a column to 0. And then I check, is 0 less than 3? Yes, it is. So I go inside this for loop. And then I check if row is equal to column. So currently row is 0, column is 0. So is 0 equal to 0? Yes, it is. Which means I move into this if statement and I do the combination on the right. So my sum right is 0 plus whatever is sitting at array 0, 0. And what is sitting in there is the number 1. So that means my sum right is now going to be equal to 1. Okay, then I come back out. So I go back, finish this statement, and then I go back in here. I increase the column by 1, and then I check again, is 1 less than 3? Yes, it is. So I go back in. Is row equal to column? So is 0 equal to 1? No, it's not. So I skip this if statement, increase column by 1, and then check again, is 2 less than 3? Yes, it is. So I check, is row equal to column? So is 0 equal to 2? No, it's not. So I skip this if statement, increase the column by 1, check, is 3 less than 3? No, it's not. So I come out of here, I come out of this for loop, and I go in here and increase the row by 1. So now I've increased the row by 1, and then I check my condition. So is 1 less than 3? Yes, it is. So I go back in here. So column is reset to 0 again. Is 0 less than 3? Yes, it is. I go inside here. Is my row equal to column? So my row is now 1, my column is 0, so it's not. I skip this if statement. That means I go back out here, I increase the column by 1, and I check my statement again. Is 1 less than 3? Yes, it is. I go in here. Is row equal to column? So is 1 equals to 1? Yes, it is, which means I go in here, and I perform this calculation on the right first. Sum right is 1, and then what is sitting inside array row? 1, 1. And what's sitting inside 1, 1 is 5. And that means my sum right now takes the value of 6. Okay, then I go through it again and again until I get through the whole double loop. Okay, hopefully that was understandable. And I won't finish the double loop. Okay, so that's great. What happens now if I wanted to do yes, I can easily make it one loop for the person online as well. But sometimes when you're starting out learning, it's much easier to understand 2 loops happening. But yes, I can. Okay, so now what about if I want to do the other diagonal? So this diagonal, what's so special about those rows and columns? How can I find them out? Sorry? Row plus column. Row plus column is equal to 2. That will be hard coding it. Not, I mean, yes, but
Plus column is equal to size.
almost.
Size minus 1.
Size minus 1, yeah. So then we're keeping it flexible as well. You're right, it would work very well for this particular one. Okay, so then we're starting to look, okay, so a few people are doing there. So row plus column is equal to size of array minus 1. Excellent. And you know what? I'm going to let you play with that code and do it yourself so that we can move on to strings, I think. Well, how are we feeling about that? Yeah? Because it's very similar code. You're just checking for a different condition. Instead of row is equal to column, you are checking row plus column has to be size of array minus 1. So your column, yeah. Okay, yeah? You can try it yourself? Yeah, I've got good confidence. All right. Oh, I hate it when it does that. Hang on, let me rub out all of this. All right, so let's do it. Okay, so what are strings? Some of you have done strings in other languages. Has anyone done strings in C? Yeah, a few people have. Strings are really weird in C. But unfortunately, we have to do them. Well, we don't really, but we do. So strings are really an array of characters, okay? But you can have an array of characters that's not a string, but you can't have, a string without having an array of characters. There is something special that defines a string as a string in C, and that is that array of characters is finished with a special character called the null terminator. And it's, where is it? I don't even have it here. It looks like this. This is called a null terminator. So that means that I can have an array of characters, and the last character in that array, so the last thing in the index, will have to be that /0 to indicate that it is in fact a string. What it allows us to do is it allows us to pulse that array then as well, to traverse through it until we reach the null terminator and we know that it has finished as well. So there's two ways to declare and initialize a string in C. You'll probably prefer one over the other, I would imagine, because one of those ways is to say that it's an array of char, which is fine, that makes sense. A string is made up of characters, so it must be an array of char. So you say char is the type, the name of the array, and then square brackets to say it's going to be an array. And then in double quotation marks, you'll say the string that you want to assign into that array. And what it will do is it will assign the words hello, and it will assign the null terminator. Or you could go to town and you could actually specify what each character is and the null terminator yourself. So obviously, you really are not going to do that because that seems very tedious to do, even for something like hello. That's not really ideal. And so when it does this, okay, when you declare this array of char and you say that you want to place the word hello in it, what happens is that it will create an array that has 1, 2, 3, 4, 5. It will have 6 elements in it because it will dedicate a space to that null terminator, and it will do it. It will kind of do it itself. So you've specified that you want a string, and it will create that string by doing that for you. So you don't need to specify the size of it because it will do it automatically based on what you have given it, just like it can deduce what you want to do when you specify and declare and initialize an array of numbers as well. And you have the numbers in here. It will assign that as the size of the array, so it will deduce it from there. Okay, so let's have a look at how it works for it. Should I do it? Yeah, let's do it. Okay, let's do it now before, and then maybe after the break, then we'll do a piece of code. Okay, so far you've used scanf to read stuff in from terminal. And you've done scanf%d, scanf%c, scanf%lf. What do you reckon you do to read in a string? You do, but you know what? You can do scanf%s, but please don't do it. Don't ever do scanf%s. Okay, it has a number of issues that will cause it to, well, it's just huge issues with memory and buffer overflows and so on and so forth. So what we use is something called fgets, because what this function does is it specifies where to read the string into, but it also specifies the length of the array. So it keeps it contained, whereas scanf%s does not keep anything contained, so you could cause some serious issues and vulnerabilities with that as well. So don't use scanf%s. Yeah.
So the issue is that because like someone could essentially like try and enter code that would overwrite like.
You can overflow as well into the buffer because %s doesn't check whether whether there is enough space for anything. It doesn't care. So you can cause, yeah, there's. Exactly. Exactly. So you can, yeah. It's just chaos, basically. But we're still printing out with %s. So what you do is you use this, sorry, I didn't.
That SDIN should be standard at the bottom.
It should be NT, yes. We should have an STDIN, standard input. Yep, sorry, there we go, spelling mistake. So you use this function called fgets, okay? And don't worry because you're going to use it quite a bit. It's a function that's written for you. You don't need to do anything. But what you do is you tell it what array you want to read it into. You tell it the length of that array. And then you tell it where to read it from. In 1511, you will only ever read from standard input, so from terminal. So it's always going to be the same, this third thing. It's always going to be, unfortunately, I made a spelling mistake there, STDIN, so standard input. But you can also read from files and other things. It's just that we're not doing it in 1511. Okay? So you're going to use fgets. We're going to use it. It's going to be so exciting. And you'll see strings are actually not that bad now that you've done arrays, and you know, it's fantastic. All right, so I think maybe actually we do have time to use the function. Let's use the function quickly. And then we'll take a break after that. Okay, so let's say I've got something that looks like this, okay? I've got a little main function. I've declared that a maximum size is 20. I've got a char array that I've kind of declared that I want to have a char array, so an array of characters, and the size of it, which is size 20. Then I've done a printf, type in a string to echo, and now what I want to do is I want to pick up that string from terminal, okay? So this is where I'm going to use my fgets command. So I'm going to use fgets, and inside fgets is I'm going to specify where I want to fgets it into, okay? So what do you think is going to go in here? Yep, array, excellent. So we're going to have array in here because I wanted to read into array, okay? What do you think is going to go next? Max, yeah, which is the size of my array. And always, 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 because we're in 1511, well, not always, but always here, you will read from standard input, which means I want to read something from terminal, okay? So STDIN. Okay, and now let's see what is actually inside there. So let's printf, and let's printf our string, and we're going to printf that array. Okay, so let's have a look what happens. Okay, so it compiles, and if I run it, it says type in a string. Okay, great, so it's reading that. How can I break it? Or how can I make it not work for me? Yeah, more than 20 characters, okay, so if I do that.
Do you not need to put slash in or backslash?
Okay, so let's see how many characters it did, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh my God, I've lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so the size of my array was 20, but it only put in 19 characters. How come? Yeah. Pardon?
No, it's because of the
No, not that. It's because of the null terminator right at the end, okay? So it took up 19 characters and then it reserved that 20th character for the null terminator at the end, okay? So even though my size is 20, I'm only going to be able to fit 19 characters in there. Okay, now how come over here I love COMP1511, I pressed enter, and here it went to a new line as well. But here it squeezed in these 19 characters and then kept the prompt on the same line. Yeah, so new line, it read the new line as a character. It fit in, so it read it, it echoed it as well. Whereas here, it filled up with the 19 characters. It never even got to the new line. Okay, I think now is a good time to have a little break, and then we'll put it inside a while loop and loop it as well. Okay, so let's have a 5-minute break, and then we will come back after that. All right.
Oh my man. I don't like Star Wars. Yeah. I have some. Oh, you know, I have the. No, I think in my recipe, I think about a blend.
All right.
It's expensive for a
It's like, mine's breakfast.
Oh. Oh, very good.
You said you didn't want any. I said I don't want any.
I'm not gonna start this.
Oh.
I used to do a lot, but like, no, really. So actually, it's not lying because.
Got to specify a size. It shouldn't have that code. Oh, maybe it should. No, it should. It's the wrong code snippet. So you just... It's the wrong code snippet. That's why that did not make sense. Sophia? Ah, Elsa. There's a few people that are called Elsa. Just throw a few around, Sophia. All right, just throw a few around. There we go. Let's wake everyone up. There was an intercept there.
I wanted to get the one layer feature and might be the better I can train it. But like the handles and everything are the same. Absolutely nothing. But it doesn't make a difference.
Sophia. Almost a nice throw. All right, so let's go back to our strings. What's happening? Is someone missing chocolates? Did someone get hit in the head? Is someone?
I think someone got his head.
Highly likely. There was a few good throws in there. All right. Strings, 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 strings. Yay, strings. Okay, so let's have a look. Let's just do a quick rehash of what's going on here. So when we did this piece of code, what we did is lots of exciting things. So here we declared an array. Yeah.
How did you collapse your main?
Just pressing where I am on the rows, and then it collapsed the whole function.
Are you using a different...
I've got quite a few things going on here, but just don't do it. It's not really, especially when you're first starting, because you collapse. And sometimes you don't see that the row numbers have changed, and you forget that there is something there. Okay, so here we declared an array of char of size max, which is 20 characters long. And spelling, obviously, a strong point here. Okay, so we've got char array max, and this one is not initialized. So remember what we just did in the other notes. I can initialize an array of char to make it a string. And the way I would do that, if I were to do that, is I could say, okay, char array, square brackets, and if I'm initializing it in double quotation marks, I can kind of write whatever it is that I want it to be initialized to. So if I write hello there, then what's going to happen is this array size is going to be given it's going to be automatically given the size of 1, 2, 3, 4, 5. So it's going to have 6 characters, which is 1 for each letter plus a null terminator to finish off, okay? And the null terminator is a special character Yep. Thank you. If you haven't noticed my spelling.
What happens if you were to, say you say printf and then you start typing something? If you include a \0 at the end of that, what happens?
Okay, so we're about to move around that string by putting a null terminator in different places. And then it'll show you what will happen. So a null terminator is a special character that indicates that we have reached the end of the string. So it's always the last character in the string. Okay, great. So that's a little bit about it. Okay, then to read a string from terminal, we use the fgets function. And this function has 3 inputs into it. Okay, so the function is called fgets, and then there's 3 inputs. So input 1 is the array name. Input 2 is the size of the array that you're reading into. And input 3 is where you're reading from. So basically it goes like this. Okay, you say array name that you are reading into, size of that array, and then also where you are reading from. Okay, and this is always going to be stdin in 1511, so it's always going to be standard input, which means that you're reading from terminal. So then over here we're printing out a string, and I'm using a %s operator. So whilst we don't want you to use a %s in a scanf, it's fine to use in a printf statement, okay? So you just basically say %s to print out a string, and then the array that's housing that string. Because it's a %s, it will know when that string finishes. It will go to the null terminator, and that's how it will print it out. Okay, so if we save this now, and then we run it again, just to rehash what it's doing, okay, and then we run it, and then we put in, and, okay, so in this case, there were too many characters present, so it's going to cut it off at 19 characters, because after that it needs an extra space for a null terminator. Okay, so then that's your 20 characters. Okay, so how is everyone feeling about fgets? Because that's going, sorry.
That's the HR.
We're just at that stage now. So what is the %f in the printf function? It is saying, this %s is saying I would like to print a string. That's what it's saying. So that %s indicates that I want to print a string. So %s indicates that I want to print a string. Okay, so there we go. Now, what happens if I want to keep doing this on repeat in a loop? Yeah, over there.
So we're not allowed to scan in.
Yeah, don't. That's right. So don't scan f at %s because there is no limit on the size, okay? So then that leads to problems. Whereas fgets limits the size of what you're scanning in so that you can't overflow out. Okay, you don't have to fully utilize all the space in your string. I could have a max of 1,000 here, okay, if I wanted to. And then if I read in something that doesn't have it, it will finish with a null terminator, and that will be the end of the string. So it will know when to finish it up. Okay, yeah.
Could we, when you use fgets, can you put the second parameter, right? Can you put something that's actually less than the size of the array, and then have the last element of the array already set to \0, so that way when you print it out, it always prints the new line or something?
Usually the problem is losing the new line.
Yeah, so I mean like, can you, if you say fgets, right, in this
Yeah.
same situation, right? Instead of say max is 20 still, right? Can you pass in 9p so that that last element of the array is
Yeah,
unchanged?
it will cut another letter, and it will just move the null terminator.
And then can you have that last one already set to like a null terminator so that when you print it out?
You can set that character. So I can move. Okay. So let's say I've read into this. This was a good question, so I'm just going to address it to everyone. So let's say in here, I've printed it out, and I've done something that is, so if I run it again, let's say my string is COMP1511, and that's the string that I've done. Okay, so now what I'm going to do is, let's say I'm going to do array at index, so let's say this has 8 characters. At index 6, I'm going to make it equal the null terminator. Okay, what's going to happen now, do you think? Okay, so now if I run it, oh, I didn't mean to run it. Let me clear it. Okay, let's compile it, and let's run it again. Okay, and if I do COMP1511 again, okay, wrong way, yes. No, it's the right way. Less than, greater than, you're all killing me. Is the array called array? Have I compiled it? Have I saved it? There's so many comments in here now, I can't even tell what's going on.
I don't think you compiled it yet.
Okay. 2, 3, 4, 5, 6, 7, 8. Oh. I forgot to print it out again. Yes, yes, yes. Okay. Yes, very good. Oh, look, I'm glad someone's on the ball. Okay, let's try this again. All right. So what's happened is I've done my string. I hope you're brushing your teeth after this lecture. Okay, so let's do this string. That's great. And then if I print it out again, it's only printing out 1, 2, 3, 4, 5, 6 characters because I've set the 6th thing to a null terminator. So what happens in here is, let's say I read in my COMP1511, and what it did is it did COMP1511 initially, and then, damn it. Okay, so at first I read this in. Okay, and then it also read in a new line over here, as you can see. So it also read the new line as well. Okay, so it did the new line, and then it did my null terminator out there. So I had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 indexes. So that was filled up. Then I said array at index 6. So this one over here, change that to a null terminator. So once this all changed to a null terminator, it can no longer see any of that. And when I print the string out again, what it's printing is it's just printing this for me over here. And then the rest of it is a null terminator. I have no more space for it. Okay, so that's, you can shorten the strings out if you wanted to. There are some ways that sometimes you want to get rid of a new line, and that's how you do it, by moving that null terminator by 1. Okay, so let's have a look how we can scan in, until forever. Okay, so we want to scan in until a control D is pressed. So how can we do that? Does anyone know how we can potentially do that?
Does fgets return something in the same way scanf does?
Yeah, so fgets can return something when we kind of finish. Okay, and that keyword that it returns, I think I even have it in a slide. Where is my slide? My slide is over here. And that lovely thing is null. So using the null keyword, you can continuously get string input from terminal until a control D is pressed. So in your assignment, you are using scanf to do until control D is pressed. It's a little bit easier with scanf because scanf, you don't have to worry. Basically, when control D is pressed, something that is returned to scanf is something other than whatever number of things you wanted to scan in. Usually it's -1, but it can be something different. So if you check that scanf is equal to 1, it just basically catches control D as well because it returns something other than 1 or 2 or however many things you actually want to scan in. But for your fgets, the key word is null. So you can keep reading until until control D is pressed, and that's the null.
What does fgets actually return? Like scanf returns the number of things successfully scanned in. So does fgets return the number of characters scanned in, or what?
Not quite. So fgets. So look at this. Have you ever seen the man command? The man command, manual, M-A-N. You can look up any function you want with it. So if you type man and fgets, you can actually find out what any function returns or picks up. It's the manual, and you can see it straight up.
But so can fgets be used for, say, like integers or something?
For what?
Integers? Like, could you enter a bunch of different integers using fgets?
So you don't usually use it. You just use it to pick up strings into arrays. But it's it's reading characters into an array. So and it's reading them as a string. Okay, so let's try and use it now. Okay, so let's do this while loop, and we will do while fgets is not equal to null, which means that whilst control D is not pressed, okay, we're going to read it in, and then we're going to print it out, okay? Okay, let's see what this does. I might just get rid of this, and this, so that we don't have any of these extras. Okay, let's see, and then we can see what we need to fix, okay? All right, so if I compile it again, and if I run it again, let's type in a string. Okay, then something is happening, don't know what. What do you think is happening that it's doing that? I just don't have a prompt, that's all. But when I press Control D, then it exits out. So what I can do here is I can print out for the next prompt, okay? So type in a string to echo. And then that will kind of take care of that nothing going on there so that you know what's going on. So if I compile that, run it again. And so you keep echoing until Control D. Then I press Control D and it exits out. Okay, so that's using that null with Control D. How is everyone feeling about that? Feeling okay-ish? It's really hard. These concepts are hard and there's a lot coming at you. It all becomes clearer when you kind of implement it yourself a little bit. Please don't be scared to ask for help as well. We are there to help you, so please, 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 ask for help. Okay, someone is asking a question in the chat, and it's what's the difference between scanf is equal to 1 and scanf is not equal to end of file. So there is only slight differences, but basically when you're scanfing equals to 1, you're checking for a whole range of things. Whereas if you're scanning just for an end of file, you're only checking for one thing, that it's not equal to an end of file. And an EOF is basically, it's a return of a different integer, usually -1, not always -1. So it's much safer to check for 1 because it allows you to view a whole bunch of things happening as well. Okay, so what else is available to us? Well, now that we've learned about strings, we have a whole range of things available to us. There is a whole new library at your disposal, and that library is called string.h. Okay, and inside that library, string.h, is a whole bunch of things that you can do with strings. You can compare strings, because I can't just say, you know, is hello equal to hello. I can't compare two arrays together just by saying is array 1 equal to array 2. That's not possible, because what needs to happen is it will need to compare it character by character. So you can write that, of course, and check if they're the same or not. But there is a function that already does that for you, so you don't have to write that piece of code yourself. So that's always a very useful one if you want to compare something. There is also something that can get you the length of the string, and it will get you the length without that null terminator. That's what it will give you. There is also functions to copy one string into another. And let's try and use a few of them just so that you kind of get to see what the different functions are that are available to you. Okay, so let's say I've got another array of characters. I've entered something. Now I want to pick up what it is that I've entered, so I'll use fgets. I'll say the array name, I'll say the maximum size, and where I'm reading from. So in this case, standard input, which means I'm reading it from terminal. Okay, so now let's just print it out just for fun, because why not? So %s. And I'll print out this array so we can see what it is. Okay, and now let's okay, we've done the movement inside the other file. Let's use string copy now, just to see what string copy does. Okay, so if I want to copy a string from one array to another, I currently have char array, so I'll need a second array to copy into. So I'll call it char array 2. And it's going to be size max, and I'm not going to initialize it because I'm about to copy into it. Okay, so then to copy an array, you use strcpy, which is the function that copies. And all of these, you can look all of these up online, what functions are inside your string library. Okay, you don't have to remember them. When I'm coding, I will often look up exactly what the function is called. I just briefly know that there is a function to do it for me, and I don't have to write the code myself. Yeah?
When you're copying from one array into the other, does the destination array need to have the same size as the original one?
Well, it depends how many characters you've got inside each one.
What happens if you try to copy from a larger array?
It's a very good question. We can try it. Very good question. Something does happen, but I think it's better seen than heard. Okay, so string copy, and then it works where you say destination first and then the source second. So my destination's array 2, and my source is array. So I'm copying from array to array 2. And then what I'll do is I will print it out. Let's print it out to check. So printf, and let's print out the string now to check. And let's print out what's inside array 2. All right, so let's try it out now. I'll clear this so that it's not... Okay, so string.c, string, and let's run it. Okay. Okay, so now I've got hello, that's the first printf statement. Then the second one I'm copying is array 2, and it's printed out the same thing. Okay. I can also do things like this. For example, I want to copy from one string to another, and I can say that this string here, I can just give it a string if I wanted to. That's okay too. So then if I run this now, compile and run it, it will now print the second thing as howdy because it's copied a howdy into it. Okay, so that's string copy. You've also got a length. Obviously, length returns an int, and that int length does not include the null terminator. Okay, so int length is equal to, and then the function is called strlen, and you can measure the length. I don't know, what should we do? Well, let's just do the array that we have, so we can give it that array to find out what on earth is going on. And we can print out. Okay, so let's compile it again and see what that one does. Okay, so now it's saying 5 because there's five letters in hello, so the length is 5 without the null terminator. Okay, so that's string length. And we'll look at one more, which is string copy, and then we do have time for command line arguments, and then we'll do a big rehash on Monday. Well, Andrew will do a big rehash with you. Okay, so let's use string copy as the last one. String compare. So basically what string compare does is that it compares two strings together character by character. So it returns, there's a possibility of what it returns, and I've just given you basically the useful one is it returns 0 if the two strings are equal, and it returns another int if the two strings are different. It returns a different int if one is bigger than the other one and one is smaller than the other one, but you don't usually need to know that. You usually just need to know when they're equal. So I could compare, I don't know, what should we compare? Let's use it in an int, in an if statement. So if I do strcmp, which is string compare, and let's compare two things that are going to be the same. So I'll compare hello and array, whatever's going to go inside array. So if the result of this string compare is going to be equal to 0, then that means the two strings are the same. Okay, and then if not, then they're not. So, you know, we can say else the two strings are different. Okay, so let's try that. See what happens there. Okay, so the two strings are the same because I've done hello and I've checked it against hello, so they were the same. But if I do, let's say I run that, and instead of that, I'll do howdy, then it will say the two strings are different because string compare will return that they're not the same, they're completely different. Yeah. Okay, so there is like it returns, I can't remember which one is which. It returns 1 if the first one is bigger, -1 if the second one, I can't remember which way it returns, but it checks it character by character. So if I don't have 0 here, 0 is when they're exactly the same. Oh, it doesn't give me how many different characters there are. What it will do is it will basically compare up to the point that it finds a difference, and then it will exit out and say they're different. So it only really compares them for equality. We'll stop checking once it gets to a different character. No worries. All right, so that's strings. That was good, maybe? How are we all feeling about strings?
Really good.
Really good? Oh, I really like that. I've got a few thumbs up. That's nice. So it's just really an array with a null terminator at the end, okay? You're just playing with characters now. Okay, so let's do, if you can replace any character just like you can replace anything inside an array at any index, you can do exactly the same in a string as well. You can literally just, I can say hello and then I can say, okay, array 2 is now equal to the letter R, and it will change it to the letter R instead. Okay, so it's the same thing as an array. It is an array, in fact.
Wait, did you run them and put hello and get the output as them saying it's the same?
Pardon?
Did you run the program and enter like hello, and did you get it saying they're the same?
Yeah. Up the top. There you go.
Did you change the size of array or something?
No, I didn't. You want me to do that?
No, because oh wait, is it at 6 right now?
It's at 6 right now. I'm keeping it small so I can see.
If it was bigger, say we had stayed with the size as 20, right?
Okay.
And then into array of 1, I had entered hello.
Yeah.
Then strcmp doesn't actually say they're equal, does it?
No.
Because 1 is of length.
That's
20,
right.
but with the
So
one-
straight away they're going to be different arrays because they can't match. There is no physical way they can do that. Someone's saying, can I run over it line by line? With the string functions, I can't really because I'm using functions that are in a standard library. So I'm literally using someone else's code. I'm using standard library functions, but they're the useful functions. Okay, I'll just show you me replacing a character, okay? So for example, I've read in I've read it in here. I've printed out the normal one. Now I can say array at, I don't know, at index 2 is equal to t. And I'll print it out again. Okay, and then let's save it. Let's run it again. So now let me enter hello. So which character is it going to change if I'm accessing at index 2 and I'm changing it to a letter T? Which letter is going to be changed? Yep, the first L, because we've got 0, 1, 2. So it should say head to low. Okay, and I really should have put a new line there, but there we go. So then it says head low. Okay, someone's saying how the string's the same if it's equal to 0. I'm sorry, that's what the function is programmed as. I did not write that function, but that's how that specific function works, okay? So it returns 0 if they're the same. That is specific to that function. So it's not like a true or false return. It returns a bunch of things based on what it's reading in. So this is why sometimes, often we will not use those functions. We'll need to look up the function just to make sure that we understand what it's returning. Yeah. Where did the howdy come from? The howdy came from over here, where I string copied into array 2. Yeah. Okay. Let's look at command line arguments, just because why not, for fun. Just keep overloading you with content today. Did someone just say thank you? That's okay, you're welcome. Okay, one more thing. Okay, I've done the replacement with the null terminator. It just means you won't print out the whole thing. So I think I'll leave Tom to answer that one. Okay, so far, we have had so much fun. Let me open up, okay. Okay, so far, all we've done is we have had a void in our main function. Okay, we have had a void. We have not given it any parameters. We have not given it any input. So now it's time to just give it something at terminal so that our code can become a lot easier and we can stop using scanf so much when we look at code. Why not? So if you wanted to read something from terminal at the time when you run the program, instead of void, this is going to be your definition for the main function, okay? There are two inputs. One of those inputs is int argc, okay? And what it stands for is it stands for argument count, okay? So it's counting how many arguments you have given when you run the program, and that's including the program name as well. And then you have something that you don't really understand yet, but you will understand after next week. And that's char star argv square brackets, okay? It is, yes. So it's going to involve pointers. You don't have to worry about it. You don't really have to understand what that star means yet to use it because, well, you just don't, not yet, okay? All right, so if I run this program, and I'll show you how it works, and I'll run through it line by line, okay? But I'll just run it first. So dcc argv demo.co. So what it means to have command line arguments is that on my prompt now, this thing over here is the first argument that I've given, okay? That's the first thing that is stored because this is an array of arguments. It's stored in your 0 index. So the 0th index of that argv gets the lovely program name. And then after that is my next thing. So let's say I want to read in, I don't know, what should we do? I don't know, COMP1511 is the best. I'm really just biasing this opinion and everyone's thinking, no, it's not after today's lecture. Way too much? Okay, so now I have 1, 2, 3, 4, 5 things on my command line. So there's 5 arguments. Yeah. What a good question. It's a 2-dimensional array. So you can access the letters in it as well. I'll talk about it. You can access each letter separately as well. Okay, so what that means is I've got 5 arguments. I know this is very exciting, but just pulse down a little bit because, yep, thank you. Okay, so then we've got 5 arguments. This is going to be sitting inside my index 0. This is inside index 1, index 2, index 3, index 4. Okay, so, oh my gosh. Yeah, I've called it something different. Yep, yeah, I was feeling not lazy, but then lazy. Okay, so what it's doing now is there are 5 command line arguments in this program, exactly what we've said. 1, 2, 3, 4, 5, because there's 5 things on the command line, okay? The first one of this is sitting inside argv0. This is always the program name, okay? So the program name, argv-demo, is sitting inside argv0. Then at index 0, okay, that's your argv. In the first index at argv1 is COMP1511, which is the first thing I put down. In the second one, it's is. In the third one, it's the. And in the next one, it's best. Okay? So what it allows us to do is it allows us to kind of get things straight away from the command line. So we don't have to scan in arguments as well. We can just read them straight from the command line and do something with them. Okay? So it's storing the command lines. Okay, so in here, the way I pulse through it and traverse this array is I did a for loop, which is how we go through arrays. And what I did is starting from index 0 until index I is at argc, because argc is the number of things that are sitting on the command line. So it's already counted how many things there are in this array. So that information is available to me. And then I increase my count. I print out the command line argument at index %d to show you where it's at and what the string is. Okay. And over here, what I've done, and that's relating to the question that someone's asked, and I really should just do a new line because you've missed it. You blink and you miss it because it's on the same thing as the command line prompt. So if I run it again and just... Okay, so you'll see that randomly there's this little s over here. And this s is referring to this printf statement over here. Okay, so this f statement, I've got a %c, and I'm pointing it. Now it's got a 2-dimensional array. What on earth is going on? And that's because I've got a string. So I'm going to, whatever is sitting inside at index 2 for my arguments, and at index 2 is the word is, okay? So the word is, and then I want the first element of that. So what it's done is it's a 2-dimensional array. So that means I can pick out a single letter. And that single letter is at index 1. So 0, 1, it's going to print out an S. Okay, so that's your command line arguments. That is a way to pick things up off the command line. Okay, but it's not, it's not all that kind of simple. So I just want to show you this. One more function that is useful for you to know that if you are going to do this. So when you're reading off the command line, what happens is that you're picking up a bunch of strings, okay, from the terminal. And if you wanted to, for example, run it to pick up numbers, so you can do some sort of calculation with numbers that are already on the command line, you can't, they're strings, they're not numbers. So there is a function to convert whatever you've read into numbers as well. And that function is called a to I. Now that function is inside the standard library.h. So that means that up here I will include something called standard library.h, stdlib.h. I'm going to say to my main that I would like to read off the terminal. So I would like to use command line arguments. So that means I'll have int argc char star argv. And then I'm going to sum up, let's say, all the numbers that are given to me at terminal when we run the program. So again, I know that an array is given to me, but the first thing I need to do is I need to convert it to a number, okay? So I'll have my command line, but then instead of printing out what is sitting inside that array only, so argv at index I, what I'll do is I'll use the function a to I with it. And what a to I does is it basically ASCII to integer, okay? So it's converting your character, whatever it is, whatever's happening up there, it's converting it to an integer format. And if I'm using sum, then I'm going to use it also with my a to I because it converts things, it actually converts it to an integer. So for example, case. Okay, so now if I run it, so I'll go a to i's, I don't know, 1, 2, 3, 4, 5, 6, why not? So that means I'm going to have 1, 2, 3, 4, 5, 6, 7 arguments. So my argc over here is going to be equal to 7 because there's 7 things on the command line. Inside argv0 is going to be a to I demo. That's going to be the name of the program. And then I'm going to start converting all of these to numbers. So that's going to be inside argv1, argv2, argv3, 4, 5, and 6. And what I'm doing is I'm converting all of them to numbers, which means that I can then sum it up. Okay. And if you can see over here, I'm printing out a number, okay? And that's why I've used the a to I over here as well. Okay, should we go through this just line by line? Yeah? How's everyone feeling? Everyone's losing the plot, too much information? Too much information? No, it's too much information. I went too strong. Yeah, too much information. Don't worry, okay? This is, you know, okay, you know what we're going to do? We're going to repeat all of this on Monday, okay? So don't worry. Don't worry if you don't understand it. We're not going to do anything with it. We're going to repeat it on Monday instead. So don't worry, it was too much information. Is this commonly used? It is commonly used, but you don't worry about it, okay? There's no exercise next week for it. It's not a, I just thought it's a nice thing to do with strings, but I overcommitted. Everyone is too exhausted by Thursday. So don't worry about it for now. We will go over it. Think about it like as a precursor, introduction to this, and then you'll go over it again on Monday. And because I've killed you with all this love of strings and arrays, I think we'll have a little early mark. So we'll finish there today. And I hope you have a good week, and a good week next week, and a really, really good flex week. I look forward to seeing your assignments.